Now it's time to learn big data and Hadoop. At first we are going to see what is big data, and then we are going to see about MapReduce, and then we are going to compare both the traditional database method with the map reducing method. How the latest technology is going to overcome the world technology in database method. First of all, we see about map reducing computing paradigm. That is, first of all, we are going to compare both the traditional database method with the Hadoop system. So in Hadoop, many enterprises are turning to Hadoop because especially applications generating big data in web applications, social networks, and scientific applications. Now, big data is a collection of data that is huge in volume, yet growing exponentially with time. It's a data with so large size and complexity that none of the traditional data management tools can store it or process it efficiently. Big data is also a data but with huge in size. MapReduce. MapReduce program is composed of a map procedure which performs filtering and sorting, such as sorting students by first name into queues, one queue for each name, and a reduce method which performs a summary operation such as counting the number of students in each queue, yielding name frequencies. The map reducing system, also called infrastructure or framework, orchestrates that processing by marshalling the distributed servers, running the various tasks in parallel, managing all communications and data transfers between the various parts of the system, and providing for redundancy and fault tolerance. Why Hadoop is able to compete with the traditional database method? The first benefit is scalability. Petabytes of data, thousands of machines, nodes have been maintained in Hadoop, but in traditional database method we can't do that. Flexibility in accepting all data formats. There will be no schema in Hadoop, but we are having certain schema for each and every query method in database, normal traditional database. Efficient and simple fault tolerant mechanism. Commodity inexpensive hardware. But in normal traditional database method, performance, we can able to see how it is works. Tons of indexing, tuning, and data organization technology has been used. Features: provenance tracking, annotation management. What is Hadoop? Hadoop is a software framework for distributed processing of large data sets across large cluster of computers. So we have two terms: large data set and large clusters. Large data set means terabytes or petabytes of data can be maintained in Hadoop. We can able to process them efficiently when compared to normal traditional database method. And large cluster means hundreds or thousands of nodes have been maintained, but when in normal traditional database method, if there is any failure in any one node, we want to maintain a replica in several ways. But in when we are coming to Hadoop, already when we store some data in Hadoop, automatically proxy server have been maintained in some other area, so we can able to retrieve it easily. So Hadoop is a open source implementation for Google MapReduce. Hadoop is based on simple programming model called MapReduce. Hadoop is based on simple data model. Any data we can able to process, but because there is no schema for Hadoop. Hadoop framework consists of two main layers. One is distributed file system, and second one is execution engine, MapReduce. So we can able to see two layers: MapReduce layer and Hadoop HDFS layer. MapReduce layer consists of task tracker and job tracker, and in HDFS layer it consists of name node and data node. MapReduce layer will give master node and slave node will be there. So task tracker will alert the job to job tracker, and it will be job after the completion of job. Automatically it will send to slave node a task tracker. And then HDFS layer, automatically name node, data node is there. Name node will have some specific orchestrate method. Orchestrate means a group of work which enables to complete it without any failure, because in a group work, all those people want to work all those people want to complete their work in a specified time. That is a throughput, the amount of work completed in a given amount of time. If anyone fails to complete his or her work, automatically total work will be get spoiled. So here data node will complete all the work and it will be stored in the name node. And then Hadoop master slave architecture. Hadoop is designed as master slave shared nothing architecture. Why we are using the master slave shared nothing architecture means because there will be no schema for this. We can able to change based on the job tracker and name node and slave node. So here we have two layer, MapReduce layer and HDFS layer. So job tracker and name node method, job tracker will be go to task tracker, name node will be mapped to data node. Design principles of Hadoop: needs to process big data, needs to parallelize computation across thousands of nodes. It is a commodity hardware, large number of low and cheap machines working in parallel to solve a computing problem. This is a contrast to parallel DBs, small number of high end expensive machines. Automatic parallelization distribution hidden from end user, fault tolerance and automatic recovery. In this, no task will fail and will recover automatically. The main benefit is, if there is any failure in normal traditional database method, we can able to recover it easily. We want to find out each and every output by giving a single query. That is, for each and every process we want to give a query. But here, if there is any failure in node and task, that it fail and it will be automatically recovered. Clean and simple programming abstraction. The main term here used is map and reduce. Now we are going to see about what is map and what is reduce. Hadoop, how it works. So main properties of HDFS is large. A HDFS instance may consist of thousands of server machines, each sorting part of file system data, and replication. Each data block is replicated many times. Default is 3. Failure is the norms rather than exception. Fault tolerance. Detection of faults and quick automatic recovery from them is a core architectural goal of HDFS. Name node is consistently checking data nodes. The second term is key value pair. Mapper and reduce are the two terms that we are going to see as an example now. Map and reduce are user code provided functions. Just need to obviously the key value pair interface. Mapper. First of all, we have consume and produce. It will take some input and it will produce some output. Key value pair, based on the key value pair, it will take the input and it will produce the output based on the key value pair. Mapper work. Reducer work. In the same way, the data which has been consumed in the mapper work, it will list the value what has been appeared and then it will produce only the distinct value. Shuffling and sorting method is applied. Hidden phase between mapper and reduce. The thing which happens between mapper and reducer will be shuffle and sort. So it is a map reduce phases. First phase is input phase, so it will take some record, and second work is map and mapper, and then third one is shuffle and sorting, and then reducer phase, and then output phase. First one is input phase, and then second one is a mapper work, and then it shuffle and sort, and then it will go for reducer work, and then it will go for the producing the output. Deciding on what will be the key and what will be the value, developer's responsibility is main. Say example, word count. So job is count the occurrence of each word in a data set. So input file has been taken here. First one is apple, orange, mango, orange, grapes, plum. So in the second data set, apple, plum, mango, apple, apple, plum. So now we have taken as an input file. Now we are going to map the file. Each line passed to the individual mapper reduces. First one is apple, orange, mango, orange, grapes, plum. As like that, we are going to split apple, plum, mango, and apple, apple, plum. So now it will be mapped. So how many times apple have been appeared in this data set? Apple one time, orange one time, mango one time. So like this we are going to split all those data: orange one, grapes one, plum one, apple, plum, mango, apple, apple, plum. Now we are going to sort and shuffle. We are going to sort it out from mapper key value splitting. You want to find how many times apple have been appeared. Here 1, apple comma 1. Here apple comma 1, third data set, and fourth data set apple comma 1. So totally 4 times have been appeared. Like this we are going to split it: grapes, mango, orange, and plum. And then we are going to reduce the key value pair. Here number of times appeared will be reduced in number of count. Apple has been appeared 4 times, grapes have been appeared 1 time, mango has been appeared 2 times, orange has been appeared 2 times, plum has been appeared 3 times. So final output will be apple 4, grapes 1, mango 2, orange 2, and plum 3. So this is the map reducing algorithm design. First one is input phase, and then it is splitting phase. Third one is mapping phase. Fourth one is shuffle and sort. Fifth one is reducer phase, and then it will produce the output. So map and reduce task. So we can able to see how Hadoop is compared with other systems: computing model, data model, and cost model, fault tolerance, and key characteristics. Distributed database is a normal database. Notion of transactions. Notion of transaction means that whenever we do some transaction, that variable should be declared before starting the transaction. If there is any failure in the variable, we want to start it from work. But in Hadoop, notions of job, it is based on job transaction. It is not on a single transaction. Job transaction total work will be computed in a one variable. So if there is any failure, automatically it will be recorded. A job is a unit of work here. So here ACID property have been maintained. Concurrency control will be there. So there is no concurrency control in Hadoop. Data model, structured data with known schema, a read and write mode. Because when we give read and write mode in distributed database, if there is any failure, automatically we can able to co-cover with your transaction. But in Hadoop, any data will fit in any format because there is no schema and semi-structured. It is only read-only mode. Because there is no schema, there is no need to have write mode. Cost model: expensive server is maintained in distributed database. Cheap commodity machines can also be used in Hadoop. Fault tolerance: failures are rare recovery mechanisms. Failures are common over thousands of machines. Simple yet efficient fault tolerance maintained in Hadoop. Key characteristics of distributed database is efficiency, optimization, fine tuning, and then in Hadoop, scalability, flexibility, and fault tolerance. So cloud computing model also, when we go for cheap commodity machines, then we want to move into cloud computing model where any computing infrastructure can run on the cloud. Hardware and software are provided as a remote service. There is no physical service will be there. If you want to purchase any space in a cloud server, we can able to purchase some 1 TB of space, and we can able to use 500 GB of space. Once again, we can able to sell the remaining 500 GB of space to the cloud server. So there is no need to maintain any permanent physical services or physical hardware here. We can able to extend our RAM up to 13 GB, 18, 16 GB. If you want to reduce up to 8 GB, we can also reduce this. So elasticity is main thing here. We can able to extend our elasticity for our service. We can able to shrink our service whenever we need. So the main theme of cloud computing is that is pay what we use. Whatever the thing we are using, we want to pay it. So if there is no need of use of in future, we can able to surrender the total cloud server to their particular cloud service provider. Example is Amazon EC2. Thank you for watching the video. Thank you.